Hey guys, so 4.6 graphs of other trig functions. Your I can statements are you'll be able to graph the tangent, cotangent, secant, cosecant, and the damped trigonometric functions. Okay, so if you look here, this is the graph for the tangent, and if you look at the tangent, what you need to pay attention to is where is it undefined. And so if you'll notice, hold on, let me get my pen working. If you'll notice, it is undefined here. It is undefined here. And so when you think about that, those are obviously going to be where your vertical asymptotes are. So take a look at your vertical asymptotes. The other thing is the period. So the period is only pi, whereas in sine and cosine, the period was 2 pi. And so your domain, where it is on the x-axis, your domain, your x values, is going to be in between negative pi over 2 and pi over 2. So your domain is going to be pi. Your range, it never stops, so it moves on forever. And if you think about it, it's constantly increasing. So your x-intercepts will be at 0, right here, will be at pi, and etc. So it's going to be every pi. And then all you're doing is you're doing the exact same thing what we've been doing this whole time. So you look at your x value. So your x value at pi over 4 is -1. Your x value at pi over 4, or at negative pi over 4 is -1, and at pi over 4 it's 1, and so on. And so that's how you're graphing it. You're just doing the exact same thing as what we did with the sine and the cosine. All right, let's move on. So now here it says you want to graph the tangent of x over 2. So what you want to think about is this is kind of like looking at the tangent of 1/2 x. That's the same thing. So if you remember, now this is all inside. So if you remember on the inside, what happens is it affects left and right, and it does the opposite of what you think. So what it's really affecting is it's affecting your period. Okay, so to find our endpoints, remember that we would take 1/2 x and we set it equal to negative pi over 2. And then we take 1/2 x and set it equal to pi over 2, because that was our two endpoints there. And so what we end up is x equals negative pi and x equals pi. So that means here negative pi, and here at pi you have an asymptote. Now, if you remember, it goes through at 0 and it's consistently increasing. So it's going to go something like this. And so if you look, so now if we go here at 2 pi and 3 pi, so 3 pi, because what it's done is it's changed our period to, instead of pi to 2 pi, so it's going to repeat itself. And then it's going to do the same thing on the other side. All right, it's your turn. So go ahead and give it a go, pause, and then I'll have the answer up for you. Okay, here's the answer. Hope you did good. Let's move on. Okay, the next thing we're going to do is we are going to sketch -3 tangent to x. And so if you remember, -3, that's your amplitude. So your amplitude is going to be 3. The negative is on the outside, which means it's going to flip it across the x-axis. And then the 2x is going to do the opposite that you think. So instead of my period being pi, my period is going to now be pi over 2. So that means that I'm going to have right here at negative pi over 4 and pi over 4 is going to be my endpoints, because again, remember we go 2x equals pi over 2. So if I divide by 2, I get pi over 4. And then if I do the same thing with negative, I get negative pi over 4. So that's my two endpoints. And then if you look, that means my period right here is going to be a period of pi over 2. And then it's going to hit in the middle at 0. And the amplitude is going to be 3. So if you remembered before, halfway in between was 1. So halfway in between now is going to be 3. So this is going to be here. Oh, but then it's been flipped. So, well, let me go ahead and graph this one. So this is what I have right now. And now my final one is it's going to be flipped because it's flipping across the x-axis, which means it's going to look something like this. Okay, it's your turn, so go ahead and pause and I'll put the answer up for you here in just a second. Okay, and here's the answer. And one thing I want to remind you is the period. Remember, to find the period, you do pi over b, or whatever the normal period is over b. So with sine and cosine, it was 2 pi over b. And of course, that's your b. So this tells you, pi over 2 tells you when it's going to repeat. Pi over 4 and pi over 4 is pi over 2. That's where that's coming from. All right, let's move on. So this is the cotangent, and if you remember what the cotangent is cosine over sine. And also what you want to think about is the cotangent is tangent, or the cotangent of x is equal to 1 over the tangent of x. Okay, so I want you to think about something. Okay, so think about this. The tangent at 0 is 0. The tangent at 45, which is pi over 4, is 1. The tangent at pi, or actually let's do the tangent at pi over 2, is undefined because it's 1 over 0. So now let's think about what the cotangent is. The cotangent is the flip. So the cotangent at 0 is going to be undefined because that's 1 over 0. The cotangent at pi over 4, or 45, is going to be 1. And the cotangent at pi over 2 is going to be 0. So what it's really done is it's kind of moved everything over, and you'll notice that now it's constantly decreasing. So that's what's happening here, is it's moved everything over and it's constantly decreasing. The range is the same thing, the period's the same thing, everything's the same except for it moved it over a bit. So if we go through here and we graph this one, so the first thing we need to think about is we have an amplitude at 2, and then we need to think about the cotangent and 1/3, which means it's going to make our period 3 pi. Okay, so if we go back to what the cotangent does, so before we had an asymptote at 0 and we had an asymptote at pi. But now, and that was our, well, let's just do that now. So that was our original, and then it was constantly decreasing. So the only thing that's changed now is this isn't pi anymore. Now this is 3 pi, and the 2 is our amplitude. So if you remember, we were 1 at pi over 4. So if this is pi over 4, that means this is no longer 1, that's going to be at 3. So if this is pi over 4, this is going to be -3. So all it's done is it's kind of stretched it. All right, it's your turn, so go ahead and pause, and I will do it for you. Okay, here's the answer. Hope you got it right. Next one. Okay, so now this is talking about all the other ones that we were talking about. So we've done tangent, we've done cotangent. So now we need to think about the cosine and the sine. So if you remember with the cosine and the sine, the reciprocal of the sine is the cosecant. The reciprocal of the cosine is the secant. So what I want you to notice here, so if you notice on this one, this is the cosecant. this is your sine. And so what happens is that now at the zeros, if you do the reciprocal of 0, that's undefined. So what's going to happen is your cosecants at the zeros are going to be your undefined. And then you'll notice that all it does is it takes this piece right here and it flips it. That's all it does. So it takes this piece here and it flips it. It does the exact same thing here on the secant. Wherever there's a 0, that's now undefined because 0 over 1 and then reciprocal is 1 over 0, which makes it undefined. So these are all undefined, and it just takes your little curve and it flips it. That's all it does. So if we take a look at this one, let's see. So the first thing I would do is I would graph the sine. So to graph the sine, 0, here's 2 pi. Remember, you do 4. And then it's at 1 and negative 1. So my original would go like this. Now, I need to do a few things. The 2 is my amplitude. And then x plus pi over 4, it means it's going to move it to the left. Pi over 4. Okay, so this is, maybe we should mark this stuff. This is pi. This is pi over 2. This is 3 pi over 2. So if I do the cosecant, that means that all of these are vertical asymptotes, and it means it's going to go like this. You're just going to flip those. Now, if I want to do an amplitude of 2, that means instead of being at 1, it's going to go to 2. So now I'm flipped here. I've moved up to 2, which means this one here is going to go to 2. So your height and your minimum and your maximums are going to be at 2. Now all we have to do is take it over pi over 4. So just take everything over to pi over 4. So even your asymptotes. So your asymptote is going to go over pi over 4. So it's going to look something like this. Your asymptote is going to be pi over 4. And all you're doing is you're just moving everything over pi over 4. Okay, so go ahead and pause and I will graph this one for you. And then you can come back on and see if you got it right. Okay, here's the answer. Everything was shift to the left, pi over 2. All right, moving along, let's take a look at the secant. And so with the secant, we're talking about cosine. So let's graph the cosine first. This is 2 pi, pi over 2, 3 pi over 2. So the cosine, remember, starts at 1 and goes down, up, and down. So this is the cosine. Now it says secant 2x, which means for the secant, so the secant means we're just going to, wherever there's a 0, is going to be a vertical asymptote, and we're just going to flip it. So here it would be something like this if I extended my graph. And then the only other thing we need to worry about is the 2, and the 2 is our period. So remember, our period is 2 pi over b, which means now our period is going to be 2 pi over 2, so our period is pi. So what I need to do is I need to change it to, I need to shrink everything. So I'm going to, if I shrunk everything to pi, that means that this one would go like this, right? So that means now what I need to do is I need to take my things and just flip them over. So I did a complete cosine in amongst pi. All right, it's your turn, so go ahead and pause and come back when you finish and see if you did it right. Okay, there you go. So one of the easier things to do is do everything to the cosine, and when you get done with the cosine, then just flip your little humps there and you're done. All right, let's move on to 15. So 15, we're talking about the damp trigonometric function, and in calculus, we call this the sandwich theorem. And so what happens is if you look at this value right here, x, so if we look here, okay, and so what they did is they said from 0 to x. So what you're really doing is you're taking your x's on either side here. And so when you do that, because one of the things you want to think about is the sign is always less than or equal to 1, right? So we're talking about how far it goes up and how far it goes down. So that's the values that we're using. We're using those properties. So what we're doing is we're saying this value right here kind of tells us what we need to go in between. So y equals negative x and y equals x. So here's what we've got. Y equals negative x and y equals x. And then finally what you do is you just go ahead and you use those as your boundaries and you graph the sign. So if you remember the sign, so the sign halfway, this is at 2 pi, right? So the sign starts at 0, it goes to the top to y equals negative x, that's our top point, and then at pi it hits 0, and then at 3 pi over 2, instead of going to 1, it's going to go to y equals x, or y equals negative x, and then at 2 pi it's going to go to 0, and then it's going to go, so it's kind of like those are your limits. So if we take a look at this one, what we're going to do is we're going to take a look at this. So it would be e to the negative x is less than or equal to, and then we've got this is negative e to the negative x of e to the negative x sine 3x is less than or equal to e to the negative x. So what we have to think about is if we did the sine of 3x. So if we did the sine of 3x, the sine of 3x would mean that our period would be 2 pi over 3. So at 2 pi over 3, we're going to do a complete sine. So if we did that, that means that a sine goes up, down, and up. Okay, now the only difference is that we have e to the negative x. So if we have e to the negative x, we need to think about what e to the negative x looks like and how that is graphed. So if we look at e to the negative x, so plug in 0 for negative x. So if x is 0, e is 1. And if x is 0 here, e is negative 1. And then if you remember, e is 2.71. So what's going to happen is you're going to have something that goes like this, trying to get to 0. So here we're doing the same thing. It's trying to get to 0. So what's going to happen with our sine 3x is here it's going to go to its maximum there, and then it's going to go to 0, and then it's going to go to its maximum there, and then it's going to go to 0, and then it's going to go to its maximum. So what's happening is it's doing something like this. So our e to the negative x's are the ones that are kind of sandwiching it in between there. All right, so I'm going to have you go ahead and go. So go ahead and stop and come back on when you're ready. So the blue one is our final answer, the blue one. Okay, so this is just shows you all of the graphs of everything. We've got the graph of the sine that starts at 0, graph of the cosine that starts at 1, where their periods are 2 pi, and their range goes from -1 to 1, and their domains go on forever. Then you go to the tangent, and the tangent, starts at 0, is constantly increasing, and notice the period is pi. So remember that the cotangent, which is the reciprocal of the tangent, starts at pi over 2, and again, the period is still pi, but it's constantly decreasing. Now, when we go to the cosecant, which is the reciprocal of the sine, so if we had the sine in here, it would go something like this. So really all we're doing is just flipping those little humps. You still have the same period. And then for the cosine, if you remember, the cosine goes something like this. So again, all we're doing is just kind of flipping those little humps. That's all you have to remember about. Okay, let's talk about vocabulary and figure out what they're saying here. So the tangent, cotangent, cosecant functions are odd and have symmetry with the respect to the origin. The graphs of the tangent, cotangent, secant, and cosecant functions all have vertical asymptotes. We looked at those. To sketch the graph of a secant or a cosecant function, first make a sketch of its reciprocal. So in other words, make a sketch of the sine or the cosine, and then just use the humps and flip them. For the function f of x equals g of x times sine x, g of x is called the damping factor. And so in other words, the g of x is what is going to contain our sine x, and the period of y equals tangent x is pi. The domain of y equals cotangent x is all real numbers such that x is not equal to n pi. And then the range of the secant x is from negative infinity to negative 1 and 1 to infinity. That's this part here. And then the period of the y cosecant x is 2 pi. All right, we're done.